Hey, great to see you again. Today we are going to read a parabola like a map. Every quadratic graph makes a U-shape called a parabola, and once you know where to look, you can spot its most important features straight from the equation. No stress, I will show you exactly what to look for, and we will draw every one. So what are these features? Three big ones. First, the turning point, the very bottom or the very top of the U, where the curve turns around. Second, the axis of symmetry, an invisible vertical line right through the turning point that splits the parabola into two matching halves, like a mirror. And third, the intercepts, where the graph crosses the axes. Now, quadratics come in three handy forms, and each one hands you a feature for free. Form 1 is the simplest. Y equals x squared. Its graph is the basic parabola, a U-shape with its turning point right at the origin, 0, 0, opening upward. That is the shape everything else is built from. Form 2 is called turning point form. Y equals a, bracket, x minus b, bracket, squared, plus c. This one tells you the turning point straight away. It sits at B, C. On the graph, the whole U simply slides, so its tip lands at B, C. We will draw one in example 1. Form 3 is factored form. Y equals a, bracket, x minus b, bracket, bracket, x minus c, bracket. This one hands you the x-intercepts. The graph crosses the x-axis at x equals b and x equals c. We will draw one in example 2. And one quick rule for every parabola. If a is positive, the U opens upward to a minimum. If a is negative, it flips and opens downward to a maximum. Example 1, nice and easy. Y equals bracket x minus 2 bracket squared plus 3. This is turning point form, so read it straight off. B is 2 and C is 3, so the turning point is 2, 3. The axis of symmetry is x equals 2, and A is 1, positive, so it opens up. The turning point is a minimum. Now let us picture it. Here is the parabola. Its lowest point, the turning point, sits at 2, 3, and the dashed line x equals 2 splits it into two matching halves that rise up on both sides. Example 2. Y equals bracket x minus 1 bracket bracket x minus 5 bracket. This is factored form, so it hands us the x-intercepts, x equals 1 and x equals 5. The axis of symmetry sits halfway between them. 1 plus 5 is 6, over 2 is 3, so x equals 3. To find the turning point, pop x equals 3 back in. 2 times minus 2 is minus 4, so the turning point is 3 minus 4. And the y-intercept at x equals 0 is 5. Now the graph. The curve crosses the x-axis at 1 and 5, dips down to its turning point at 3 minus 4, and the axis of symmetry stands at x equals 3, with both sides perfect mirror images. Example 3, an 8R style one. Y equals minus 2, bracket, x plus 1, bracket squared, plus 8. Careful, x plus 1 is the same as x minus negative 1, so b is minus 1. That makes the turning point minus 1, 8, and the axis x equals minus 1. Now a is minus 2, negative, so it opens downward. The turning point is a maximum, and the biggest value is 8. For the x-intercepts, set y to 0. 2, bracket, x plus 1 squared equals 8, so, bracket, x plus 1 squared equals 4. X plus 1 equals plus or minus 2, giving x equals 1, or x equals minus 3. Now the graph. An upside-down U with its peak at minus 1, 8, curving down to cross the x-axis at minus 3 and at 1. Where does this show up in real life? Anything that flies and falls. Say a ball's height is h equals minus, bracket, t minus 3, bracket squared, plus 9, where t is time in seconds. It is in turning point form, so the turning point is 3, 9. And because A is negative, that is a maximum. So the ball reaches its highest point, 9 meters, at 3 seconds. When does it land? Height equals 0. Bracket. T minus 3 squared equals 9. So T minus 3 is plus or minus 3, giving T equals 6. It lands at 6 seconds. The whole flight reads straight from the parabola. Quick recap. Every quadratic graph is a parabola. Turning point form. A bracket, x minus b squared plus c, gives you the turning point b, c. Factored form. A bracket, x minus b, bracket, x minus c, gives you the x-intercepts b and c. The axis of symmetry is the vertical line through the turning point. Positive a opens up to a minimum, negative a opens down to a maximum. And for the y-intercept, just put x equals 0. Now you try. Pause the video and do these 5. 1. For y equals, bracket, x minus 4 squared plus 2, state the turning point and axis of symmetry. 2. For y equals, bracket, x minus 2, bracket, x minus 8, find the x-intercepts and axis of symmetry. 3. For y equals minus, bracket, x minus 1 squared plus 5, does it open up or down, and what is the maximum value? 4. Find the y-intercept of y equals, bracket, x minus 3, bracket, x plus 1. 5. For y equals 2, bracket, x plus 2 squared minus 8, find the turning point and the x-intercepts. Ready? Let us check them together. Question 1. Turning point form gives it away. The turning point is 4, 2, and the axis of symmetry is x equals 4. Question 2. The x-intercepts are 2 and 8. Halfway between them, 2 plus 8 over 2 is 5, so the axis is x equals 5. Question 3. A is minus 1, negative, so it opens down, and the maximum value is 5. Question 4. Put x equals 0. Minus 3 times 1 is minus 3, so the y-intercept is minus 3. Question 5. The turning point is minus 2, minus 8. For the x-intercepts, 2, bracket, x plus 2 squared equals 8. So, bracket, x plus 2 squared equals 4. X plus 2 is plus or minus 2, giving x equals 0 or x equals minus 4. Superb work! You can now read a parabola like a pro. See you in the next one.